Hey yo, what's up my little coders? In this tutorial, I'm going to give you an introduction to a Spring Boot. A Spring Boot is one of the most popular Java-based frameworks. It provides powerful default configurations which allow developers to quickly create standalone and production-ready applications. It helps to reduce a lot of boilerplate code, and it's widely used for building microservices and web applications. And now you might be wondering, what do I actually mean exactly by building microservices and web applications? Let me give you a real example very quickly now. Imagine that you're navigating to a CoinMarketCap website to check the current price of a Bitcoin. On this website, we obviously have some UI components which are in charge of visual representation of this website. And also this UI displays some data to us. And a lot of data which we see on this website is not a static data. For example, here's the data about some markets on which Bitcoin is sold. If I open the DevTools and go to the Network tab and refresh my page, we can see some API calls made by this website. Here's for example a GET request, which the website is sending to its own API to fetch some data. So in this case, the UI sends a GET request to a market pairs endpoint and asks for a market pairs exactly for a Bitcoin and asks to return the first 10 values. If I open a response body from this GET request, we can see exactly 10 rows of data. So after the UI received a response from this GET request, it presents the data from this response in this table. For example, here we can see a market pair value which goes here, then the price goes here, then volume gets rounded by the UI and goes here, and so on. But also, sometimes instead of fetching the data, you need to create or send some data as well. Imagine that you want to log into this website and you type your login and password details. In this case, I'm just typing some random stuff. But then, when you hit the login button, the data is sent with the help of a POST request. In this case, we send the password and login details and also some other things on top. So this is how a lot of web applications are built. And all of what I just have showed to you in the Network tab is called a REST API. So REST API allows different systems to communicate and exchange data using different HTTP methods. And with the help of the Spring Boot, you can create your own REST API as well. And this is what we're going to do in this tutorial, as you already could guess. And to start very quickly and to load all of the dependencies which we might need for our Spring Boot project, we can use Spring Initializer web page. So if you just simply navigate to start.spring.io webpage, we can just simply specify here what we need. For example, for building our Spring Boot project, I would use Gradle, so I can keep it as it is. Then Java stays as it is. After that Spring Boot version, I would go for this recommended one, it should be fine. Project metadata, I would just, skip it and keep everything as it is. Then packaging as jar, this is fine. Okay, now the Java version. This is actually a very important one. You need to select the same Java version as you have installed on your machine. In my case it's Java 11, but in your case it might be different, so make sure it's matching. Otherwise, your application would fail. And the last but definitely not least are our dependencies. So Spring Initializer supports a lot of different dependencies. For the simple Spring Boot project, we need to select a Spring Web dependency. Let's do it now. However, there are also tons of other dependencies which you can add on top. For example, a Lambbook library which can help you to remove a lot of boilerplate code, then support for different databases and so on. But since it's an introduction tutorial, just a Spring Web on its own is enough. Okay, now since we have selected everything, we can just simply press a generate button and it would generate our project which we can download and simply open through our code editor. To do that, let me just quickly unzip it. After that I can go inside my project folder, right click on the build.gradle file and just simply open it with my code editor. In my case it's IntelliJ. Alright, it might take some time now to load and build the project, let's wait a bit. Okay, now we can go to our class which was generated for us. Here you can see a Spring Boot application annotation, which indicates the main class of the application, and it also provides necessary configurations and functionalities to run a Spring Boot application. If I run this main class, let's see what happens. Here in the logs you can see that it says that Tomcat started on port 8080. So if I open my browser and type localhost 8080, you can see that we have a web page running, but we get an error because we haven't set up anything yet. Let's do that now. And for that, we need to create a new Java class. Let's call it a myResController class. And this ResController class will be responsible for handling incoming HTTP requests and returning appropriate responses. And in order to achieve this goal, we first of all need to annotate this class with a ResController annotation. And when your class is annotated with a ResController annotation, it means that you can implement different HTTP methods inside this class, such as, for example, get, post, put, delete, and so on. Let's start with a simple GET request first. So, when we are creating HTTP requests, we need to specify what kind of HTTP request it's going to be. For a GET request, we need to add a GET mapping annotation. After that, we can create a simple method below this annotation. Let's say that the return type is going to be a string. Let's also give this method a name, and let's just return a hello world string, simply as that. Now, if we go back to our browser and reload the page, we can see that instead of an error, we get a hello world string. And this is the beauty of a Spring Boot. We just needed to add few annotations and we have a simple REST API which now supports a GET request. Simply as that, guys. However, in most of the cases, the REST API would need to support more than one GET request. How can we distinguish between different GET requests? Let's say if I create a second GET mapping, which would return a hello friend string to me instead of hello world string, the way to distinguish between these two GET requests is to give them unique request URLs. For example, for our first GET request, we can say here that it will be accessible only by the following URL, hello/world. And for the second GET request, we can do a similar thing, hello/friend. So if I run my program and go back to the browser, in this case the hello/world URL returns hello world to me, and the hello/friend URL returns hello friend to me. Very simple. But okay, let's think about something a bit more advanced. Imagine that we have an online shop and we want to sell some products on it. Let's imagine that we want to build a REST API to be able to store, fetch, create, update, and delete the data about our products. And let's start by creating a model class which would represent our product. Let's say that our product would have 4 attributes. A product ID, which is a string, then product name, which is also a string, then price of a product, let's say it's a double, and a product description, which would be a string. Now let's generate simple getters and setters quickly. Alright, let's move on. Now inside our controller class, let's create a list of products to store our products. But yeah, usually you would store your data in a database, but since it's an introduction tutorial, let's use a simple array list today for the simplicity. Let's create a new GET request to return our list of products now. Let's say that it will be accessible via products URL. And since the list of products is initially empty, let's populate it with some data here, at least for now. Okay, if I run my code now and navigate to the following URL, we can see a full list of products, which is amazing. However, sometimes instead of fetching all of the products at once, you might want to just fetch one particular product by its ID. For that, let's create one more GET request quickly. Here we need to extend our request URL to include the product ID. This product ID is our pass variable. And inside this method, let's add a simple logic to iterate through our list of products, and in case if we find a matching product with the same ID inside our list, we would return it. Otherwise, we would return null. Alright, let's run our code and let's see how it works. You can see here that if I provide an ID as part of request URL, we are getting a single product. And if I provide an ID which doesn't exist, we get no results. Okay, this is good. Now our REST API has all of the GET requests to return our data. But what about creating a new data? For that, we need to implement another HTTP method which is called POST. A POST request is in charge of sending and creating a new data. We need to use a POST mapping instead of GET mapping now in order to achieve it. Let's say that our POST request URL would simply be products. Now, since we would be expecting some data to create a new product, we need to specify our request body here, which our REST API would be expecting as part of this POST request. Let's say that our API is in charge of generating the product ID by itself. For that, we can use a UUID class and get random UUID method from it. After that, we can set this generated product ID for the request body which we get. And in the end, we can just simply add this product to the list and return the generated product. And we can also remove our fake data now, which we generate as part of our GET request. And let's run our application now. If I send a GET request, we can see that no data is returned, and this is because we just have rerun our application and our previous data was stored locally, so this is expected. But let's try to create some new data via POST request. For that, we need to use a Postman application as one of the options, since we would not be able to send a POST request via the browser that easily. Here in Postman, we need to specify the HTTP method as POST. After that, we need to provide our request URL, and also we need to provide a request body. We need to follow our product model schema here. So let's give this product a name, a price, and a description. And the product ID would be generated by a REST API itself, so we don't need to provide it here. Also, one important thing is that our POST mapping expects the request body to be of type JSON, because JSON is a widely used format for representing structured data in web applications. And when the request body is annotated with the request body annotation, as in our case, then a Spring Boot automatically performs content negotiation and attempts to deserialize the JSON payload into the specified Java object. That's why in Postman we need to select JSON for our content type of a request body. And finally, we are ready to send our POST request, so let's hit the send button now. We got a status code equal to 200, meaning that our request was successful, and also our REST API generated a product ID for us. If we go back to the browser and refresh the page, we can see that this product is returned by our GET request. And if we send one more POST request, we should see 2 entries returned by a GET request. Alright, now we can fetch and create the data with the help of our REST API. But what about updating an existing data? For that, we need to implement an HTTP put request which is in charge of updating the data. We need to have a put mapping, and this put request should expect a product ID as part of a request URL, so that we would know which exact product we need to update. And apart from a product ID, we need to have a request body which would represent an updated product. Let's have a simple for loop to iterate through all of the products. In case if we find a matching product, we need to override its values with the values from an updated product. And in case if we don't find the product with the ID from a request URL, let's just throw an exception, simply as that. Okay, let's run our application so that these changes will become available. And since we are not using the real database for the simplicity of this tutorial, we need to send a POST request again to create some data, because the previous one got lost after a rerun. Okay, let me hit the send button again. We just have generated a new product. Let's validate it in our browser by sending a GET request. Yep, here it is. Now let's copy the ID of this product and let's try to update it with a put request. So our put request URL would be localhost 8080/products/product ID. We also need to have a request body which would represent an updated product. Let's copy paste it from our post request and let's modify it a bit. Let's change the name and the price of this product. Let's also not forget to change the content type from text to JSON, because our REST API expects a request body to be of type JSON. And now let's hit a send button. We can see a response code equal to 200, meaning that a request was successful. We can see an updated product which came as part of a response body. And now, if I go back to the browser and refresh the page, we can see that an updated product was returned to us by a GET request. So everything works as it should, which is amazing. Now we can fetch the data, we can create the data, and we can update the data. Let's also implement a delete request to be able to delete the data as well. And this is going to be very simple. As a template, we can just copy our product by ID method from one of our GET requests. Let's change the method name to a delete product by ID. Let's change a mapping from get mapping to a delete mapping. And we're going to delete a product by ID so our URL can stay as it is and our pass variable stays as well. Now, let's modify a for loop a bit so that we would be able to get an index of a product which we want to delete. So if products.getI is equal to the product ID, it means that we found the product with this ID in our list. So we can just simply call products.remove to delete it. And in case of a successful deletion of a product, let's return a string which would say that the product with this ID was successfully deleted. Otherwise, let's throw an exception, meaning that there is no such ID. Let's run the code and let's test it now. Once again, we need to create some data, and we can do it with the help of a post request. I will quickly create 2 different products. Cool. Now let's say that we want to delete the second product. Let me copy an ID of it, and let's go back to a postman. Let's select an appropriate HTTP request method. The request URL would look like this. That's all what we need. Let's hit a send button now. Okay, we got a status code equal to 200, meaning that the request was successful. We also got our message back. If I refresh the page with our GET request, we can see now that the product was indeed deleted from our list. It means that everything works as expected. Perfect. We did a good job, so, well done. But as I have told you already, usually for storing the data, you would use a real database and not a simple array list which is saved only locally. And if you want to see a tutorial on how to create a REST API in Spring Boot using a real database, please give this video a like and subscribe so that I would be able to see that it's needed. And also, for your future learning, I would advise you to watch my previous video on my channel in which I explain what is a dependency injection in Spring Boot. A dependency injection is extremely important concept in the Spring framework. So make sure you watch that video as well. The link will be in the description below. And yeah, I hope that now you understand what is a Spring Boot and how to build a REST API with the help of it. Thanks for watching, guys, and I wish you a good day, and I will see you in my next videos, guys. Good luck!